Hi there and welcome back. For those of you who are joining first time, I am Hasid Thanki, the founder of presentation series called Intro to Individual Life Underwriting. We started with reviewing resting ECG in our last session. So let's continue reviewing resting ECG. And in this session, what I will do, I will explain the different electrical events that occurs during one complete cardiac cycle. So with that, let's start. As we know, right and left atrium, and the ventricle. Now, here is your friend. This is the sinus node. In a normal heart, the electrical activity or the depolarization starts with SA node or the sinoatrial node. So once the sinoatrial node, SA node fires, what will happen? It will ignite, it will fire the immediate myocytes. So it will start firing the surrounding myocytes, and it will go on to the next and further next and further next, and likewise the entire atrium, both atrium. This is called the first electrical event where SA node fires and both the atriums gets depolarized. Now you may notice that SA node fires like this, so the electrical activity that occurs during the process of both atrial depolarization, the overall cardiac vector that would be generated would be like this. So it is going downward and leftward. And why is that? Because SA node is located upward and rightward. Make sense? So the vector generated would be like that. It will have a moderate velocity and it will generate a moderate vector as opposed to a real big vector, as happens when the major portion of the ventricle depolarizes. Okay, so this is the sinoatrial node fires both the atriums. Now there is a fiber insulation here. So nothing goes from atrium to ventricles except for one window, and that window after the depolarization of both atriums, nothing goes through the ventricles except there is one window, and that window is AV node. So the next electrical event occurs is the AV node. So that is this one. Now when you look at the AV node and when you look at the heart, AV node is too small tissue, right? And AV node is compared to Purkinje fiber system that we will soon be looking into. The cells in Purkinje fiber system versus the cells in AV node are different. AV node has a modified myocardium tissues. So it has a calcium, it has a multiple cells. If I draw the AV node here, it has a multiple cells. And because the AV node itself is too small, because of the dimensions of the cells, multiple cells, the conduction is so slow that in medical terminology we call that heart is silent, or heart just whispers. So nothing gets recognized on the ECG paper, no activity as such. So that's how the AV node works. As opposed to the Purkinje fibers, let me draw here the rest of the part that we need to know. Now these are the right and left bundle branch block, bundle branch, not the block, but the right and left bundle branch, and it has Purkinje system and the Purkinje fibers. So in a complete cardiac cycle, the first event happens is the depolarization of both ventricles, and the overall cardiac vector goes like this. Okay. Then the second electrical event occurs, that is the AV node, stimulation of the AV node. AV node is too small. The way cells are within the AV nodes, AV node just whispers. We don't see any activity on the ECG tracing. So that is the second event. Then what? From AV node through bundle of His, it quickly passes through the left and right bundle branch block and through the Purkinje system and fiber. It rapidly takes the process of what we call ventricular depolarization. Now, the ventricular depolarization, there are three aspects. First and foremost, there is a septum of the ventricle gets depolarized. Now, the septum of the ventricle is polarized by left bundle branch block. Make a note of it, left bundle branch block, and not the right bundle branch block. Okay? And why is that? Because left bundle branch, there is a connection here. There is a connection here. So, through left bundle branch, this portion, what we call the septum of the ventricle, that gets depolarized. Okay? Because we are talking ventricle, so the conduction system or the velocity is quick, faster. And because it goes from bottom to top, it will create vectors like this. So it goes from bottom to top, from left to right. So if we have to draw a cardiac vector, the cardiac vector for that would be like this. So this one is SA node fires, depolarization of both atria. The stimulation of the AV node is silent. Nothing gets noticed on the electric paper or our ECG tracings. Then through AV node, through bundle of His, it goes through the left and right bundle branch, and through Purkinje system, the fiber, it gets into the ventricles. And in ventricle, the first thing happens is the depolarization of the septum. Septum portion of the ventricle gets depolarized first. Okay? And then it quickly moves and it depolarizes the major portion, what we call the apex. The major portion of the ventricle, both ventricle, simultaneously gets depolarized. So think what happens. So this, and likewise everywhere. So it goes from, there is a inner cardium, there is a middle cardium, and there is outer cardium. So when the major portion of the ventricle is depolarized, so it is moving from inner cardium to outer cardium. And it happens both, in both ventricles. So as a result, what happens? All these vectors are simultaneously generated. Now you may have noticed in your study material that left ventricle is 3 times thicker than the right ventricle. Okay. So when multiple vectors are generated, if left ventricle is 3 times thicker than the right ventricle, obviously the vectors generated by the left ventricle are more powerful, more strong, and very, very powerful, very big. So, and likewise the right ventricle also is being depolarized. So the vectors are also generated there as well. So when simultaneous vectors are being generated, if we have to draw one overall, we can consolidate and we can have one single consolidated cardiac vector during this significant electrical event. So what do you think? How would it look like? So it goes like this. And why is that? Because the left ventricle is powerful, so it would dominate, and that's how the vector form would be going that way. So the first is the atrial depolarization, then the stimulation of the AV node, then the stimulation of the basal portion, a septal portion of the ventricle. Then comes the major portion of the ventricle, and then what happens, the Purkinje fibers, they go all over, and then eventually and finally they would cover the basal portion of the ventricles. So ventricular depolarization occurs in three aspects. First is the septum of the ventricle gets depolarized, then we have the major portion of the ventricle that gets depolarized, and then the basal portion of the ventricular gets depolarized. Okay, and this one will have a vector like this, moving from downward to upward and moving from left to right. Okay. So if you notice in this complete cardiac cycle, what has happened, there are 5 important events that has been portrayed here. First is this. This is the first event about the depolarization of atriums. Okay, moderate vectors, moderate velocity. Nothing gets noticed on the ECG paper at the time of the stimulation of the AV node, because the AV node is a small tissue compared to the heart, plus the composition of the AV node is such that it slows down the process. It has a calcium as opposed to the sodium when we are looking at the Purkinje fiber. So that is the second event that takes place. Then the third event is the septum of the ventricle gets depolarized. Then the major portion of the ventricle gets depolarized. And then finally the basal portion of the ventricle gets depolarized. Now, if you are thinking logically, a question may occur that in this process, what happened to the repolarization of atriums? Because in my prior session, I was saying that once the depolarization is done, then what follows is the repolarization. So where do we see the repolarization of both atriums? If you are thinking along those lines, then that's a good question. Dear friends, what happens is this. Compared to both atriums, and when we look at both ventricles, the ventricles are powerful, number one. Number two, atriums are smaller compared to ventricles. And atrium repolarization, remember in the first session, and independent of that, the repolarization is a slow process. Whereas here in the Purkinje system and in the ventricle, the cells are such, myocytes are such that it fires quickly, the depolarization dominates and it takes over. So the atrial repolarization is masked on the ECG tracings by the ventricular depolarization. Atrial repolarization on ECG paper is masked or covered by the ventricular depolarization, and that's why the atrial repolarization is not seen on our ECG tracings. Okay, so let's take a break here, and when we meet again, I will continue to correlate this different electrical event into how the ECG patterns, how the waves, segments, complex, how they are formed. So we'll meet again. Take care.